Welcome back to the Klipshow build series. I'm excited about today's episode because we're tackling the most complex feature yet, a complete real-time Klip queuing system that both our viewers and streamers and our OBS source, which is at the heart of Klipshow, all work and function together very smoothly. This is something we'll need to spend a lot of time on because this is a core feature and we need this to be something that can scale and work without a ton of edge cases to account for. In the last episode, we got our basic AnyCable alerts proof of concept working. Today, we're going to take it to the next level by introducing a Semaphore pattern queuing system that's going to handle these clips actually playing for us and making sure that they're displayed anywhere the streamer or the viewer needs to see them. In this episode, we're going to showcase a little bit more advanced patterns for Rails. We're going to go over a polymorphic association setup. We'll be making a custom React hook to be able to subscribe to our AnyCable channel and make sure that the front end UI is synchronized to those events. We'll do a little bit of refactoring in the form of namespacing. We went over that in a previous episode that we might do that to make it a little more explicit for our model names. We also had to get Chrome debugging working in OBS directly to be able to find a weird edge case that we had while working through this. And of course, it wouldn't be a complete episode without running into some problems with our system integration tests. We'll go over that as well. So if we look back in our Claude mockup here originally, it came up with a lot of good stuff I think we can build off of. There's a lot going on here, and the first thing that I want us to do is to build out this quick trigger clips area. So this will be essentially using the same kind of StreamerKlip card that we've been working with, but we'll have the ability to actually turn it into a card that we can click from our dashboard here. So let's get started on that. So just ask Claude what would be a good controller name for this live control controller, because live control felt a little confusing, and it spit out an actual pretty good response. Since we're starting to expand this streamer dashboard functionality, it's making sense that it would recommend doing kind of like a namespace for streamers and dashboard, and that would give us this kind of scheme here for our files. So it would be app controllers, streamers, dashboard, live controls controller, and then the actual controller itself would be namespace like this. So this is going to take a little bit of work to get this going, but I like this approach here because I think we're getting to the point where this is going to get out of hand if we don't have a strategy in place for proper namespacing and that kind of thing. All right, before we actually, I tried to have actually GPT-5, please Sam Altman, don't sue me for saying Claude before. I tried to have Claude, or Cursor, I'll just say, do this conversion to the new namespace here, and it started to go about it, and it didn't look like it was doing the right thing. So that was a little too ambitious, I think, for this to kind of do. I was trying to experiment with it, so I stopped it, undid all of the changes, and thankfully we're back to where we should be with everything working. So I'm going to get a clean commit in. As you can see, we've got quite a few changes here. I'm going to get a clean commit in before we go down the path of setting up all this namespacing stuff, because I anticipate this could break a lot of stuff that will be trouble for us. So we're just trying to get ahead of that by checking all of this into version control before we get started. Okay, we're actually going to abandon that idea because I realized it would change the URL here. I like having it just /widgets and that kind of thing. So if we're going to do that namespacing, we might later on configure this to be in a subdomain just for this app. So we'll keep trekking on for now because I don't want to have a long URL kind of scheme here going on. So we'll back burner that for now. So we're just going to call the controller live control controller for now. It's a little weird, but it should be fine. So that's where that will start. We'll then need to add a new folder for it. So we added a show.html.erb file underneath live_control. We're just going to have some placeholder text there to make sure that we can get it to render and make sure that my naming and everything is correct. We, of course, will need a route to go to it. And the cursor auto completion seems to have gotten it right there. Now, if we go into the terminal and see what live control routes got created, this looks like exactly what we need. In the dashboard layout, we'll need to add a link to it. And then to follow the emoji theme here, I'm just going to add a lightning bolt, and we'll more than likely switch those out for something more appropriate later. But AI got us started on this, so we'll keep it going because for now it looks kind of cool. Okay, and back in our dashboard here, we have our new link showing up. If we click it, we're getting the view showing, but it's not rendering the correct layout, which is why we don't have the dashboard on the left there. To fix that, we should just need to include our dashboardable concern. If we refresh, now we can see that we have our page rendering here. The reason the title is not changed is because we need to add that content for block, which we'll do now. So in the live control, we'll add content for. Okay, let's see if that works. Live control, excellent. And then referring back to our mockup here, remember we're trying to emulate this functionality here. So we'll just have a heading in one of these cards, I think would be a little bit more appropriate. And then we'll go from there. And we should be able to leverage some of the existing StreamerKlip React component functionality to have a good lead on what a good way to build this out actually will be. Since we've added a new view and a new directory, we have to remember to add that as a source in our dashboard style.css for Tailwind. So we'll just notate that by specifying source. Under the views here, we'll go source, views, live control, everything under that directory. Now, if we go to our show page, we see all of our styles are getting lined up. I think we may have we might have too many cards here. I'm trying to emulate what we have in the clips area here. So yeah, this looks like we'll have to adjust that, but we're making progress here and you'll see what we're after here in just a moment. We're going to be reusing this clip card component and we have some conditional set up there to have a different actions component inside of this bigger component render if it's either being shown here in a live type or in the clip library here if we had any public clips that the streamer didn't already have. So this is how this is coming together so far. So in that clip card component here, we're able to reutilize this component for two different contexts that we just went over there. And we're doing that mainly by specifying a new type prop that we'll use for this display actions function here. And if we go down here, there's a few, if we're displaying the TikTok preview, this handles all of that. And then beneath that, where the actual actions is, this will be the experience for adding the title and the clip price and everything from the clip library, or we can use it here to trigger this trigger live component that we just made. And we're following this pattern here, just kind of basing it off of that type prop that we'll send in, and it will spit out the actions experience that needs to be associated to that component. And then in the trigger live component so far, we just have some placeholder text here. Let's turn this into a button that we can have be what the streamer presses in order to actually trigger the clip. Okay, so we just changed this into a button and we stole the styling from the other button that we're using here from the library and just try to keep it on theme. We might pull this into its own component so we can reutilize those kinds of things in the future. I think that's going to be a future optimization for sure. We're just trying to be gritty with our time and getting this functionality going. So we have just a basic button here in this component. This component is where we'll handle the AJAX request using our KSFetch function in order to trigger the corresponding controller action that will trigger that clip video ID from the live control controller. So we're just going to change this on click to something like trigger clip. We will need the clip prop or this here. Import KSFetch. Okay, so let's see if we can set this up to take a post request. We'll just have it on the trigger clip endpoint here. Again, we'll most likely have this namespaced in some way to be necessary to the streamer side of things. So for now, we'll keep it just trigger clip. When we go to introduce the client side clip triggering and all of that, we'll have to develop another approach to make sure we can distinguish between the two, because they'll be set up differently for their authentication token and that kind of thing. But let's see if we can make this work on the back end now. This is kind of what I'm thinking we could have work when we trigger the button here. So let's go to our controller, or our routes file actually first. And we might be able to just simplify it by calling trigger clip. Yeah, I think trigger clip might be a little more descriptive. Okay, so we'll want to make sure that we're looking in the current streamer clips. We'll pass it in that clip ID so we can treat this as a streamer clip then. I don't know, it's just a little confusing, the clip and streamer clip functionality. It's a little hard to convey that here. So we'll have the actual clip ID sent in because that should still be fine. So we're going to copy the same payload from our test action here on the widgets controller just to make sure we get everything correct. Okay, I think this should be enough here to get this working. So basically when we go to trigger a clip, we're going to find the clip that belongs to the current streamer by scoping it to the, I just saw that we had to change find to find_by, and the reason for that is we're passing in a parameter key here. We're not finding it by its ID, so that is actually correct. Good call out, cursor. So we're scoping all the streamer clips that we're going to look for to make sure that this isn't, they're triggering clips that they don't have the permission to. We're making sure that we're circumventing that by always going this approach. So current streamer, streamer clips, find by that clip ID that we'll pass in. And then we're using the ActionCable server.broadcast, which we should still have set up and working properly. And we're following this convention here. So this is just the payload that we're sending. This is what gets converted to JSON and ultimately digested by the front end application side of things that actually parses that and displays the clip. So this could have been anything. This is just, it just takes a hash argument here and it automatically serializes it for us. And then we're going to leverage our existing Flash message functionality here. If we get to this point, we'll go ahead and render a success message on the front end so that the streamer knows that the clip should have gone through. Okay, let's go ahead and test the trigger button here. I actually think this might work. And I still have the browser source set up, so it's not functioning here. Let's look in our console, see if we're having any issues. Ah, okay. We're not having this recompile, or we didn't save it, perhaps. Prop types is not defined. There we go. Okay. Import prop types from the trigger live component there. Forgot to import that. Okay, go ahead and clear the console. Click the trigger live button. Clip was triggered successfully, but we're not seeing it on our OBS there, which we were expecting. So let's take a look. Okay, great. So the issue there was I was passing in the wrong channel name here for the event to broadcast to. And a pattern that I was seeing is that they would have this broadcast, they'd have these broadcast messages in the actual channel itself here. And I don't see a reason not to do that. So we may move to that in the future so that, you know, it's more concise where these are coming from. But as you saw there just on that screen, that was a TikTok from my gaming channel there. And right away, what we're noticing is that was a long clip and we triggered it, and there's no way for us at this point to be able to pause that or to immediately end it or anything. So we might want to expand next on being able to pause the current clip that's playing and start to introduce that queue system and see what that looks like. So I had Cursor create a queue element here that we could kind of work off of, and this is what it came up with, which we might be able to work with a version of it. But we also have an issue here with our card not showing the proper amount of spacing. So we're just currently working on that. And this is all markup that Cursor created for us. And we're just going to move this into a partial underneath the live control here so we can keep this view nice and neat and we can understand the flow logic for rendering the different partials a lot easier. I'm just going to call this queue.html.arb. So we had an extra closing div here, it looks like, and that was causing the issue with the gutter not working there. There's little stuff that you run into. The more that I'm thinking about how we're actually going to encapsulate the functionality of getting these clips that are going to be in queued, I'm thinking we might just need a React component because we're going to need to create a ActionCable consumer to be able to, in real time, show the queue that may be updated from users or from the streamer themselves and that kind of thing. So we're going to modify that a little bit actually and not go with just a Rails partial there just yet. So we just created our clip queue component here and we're following the same convention as far as directory placement and everything with that. In the dashboard.js file, we are importing the clip queue so that we can render it from our view. And then we're just returning a generic div here to make sure that it is rendering correctly, and then we'll build off of it from there. Okay, and it is showing at the top here, which is what we wanted. Okay, so building this out a little bit, we're just going to use a standard Flexbox container. Using Flex2 here, this will make this container take up about 2/3 of the page, and then this will take out the remaining third. And as we can see here, it's just text, but we can highlight over them and show that this is getting close to what we have here in our original mockup that Claude created for us. We're actually making these two card wrappers so that they have this kind of background here, and we'll give them a gap here as well. Okay, so we're modifying this a little bit more here. We're just going to use the use state here for the clips that are in queue, which will be an array, and then the current clip will be an actual object. And then we're just making some conditions here to display no clips in queue if there aren't any, or we'll just start with displaying the clip title for now. And what we currently have in the dashboard is this, and it looks like it's coming along. Okay, so backing up slightly here, we went into diagram mode, and we need to make sure that the solution that we come up for this queuing system is going to accommodate all of the known use cases thus far. So far what I've come up with is a clip will be triggered, and in this scenario here, we're assuming that there's an OBS browser source and someone on the live control in the dashboard. And these yellow lines indicate a persistent connection. So we're leveraging WebSockets whenever I point to one of these areas here. We're leveraging the underlying real-time connection that will be set up for all of these sources. So when a clip is triggered, Klipshow will digest it, send it to something like a clip, send it to something like a trigger clip service. And what that will do is add it to the queue in the database in Postgres. And the schema I'm thinking for this StreamerKlip queue will hold the StreamerKlip ID, which will be a foreign key to the StreamerKlip on which the clip is being triggered for, the streamer ID itself, the position. This will be a numerical value, and this is what we will do to make sure that when a clip is triggered, whether it's being sent for the first time or a subsequent time, it will maintain its position in the order it was originally received in. I'm also thinking we'll store the triggered by as a foreign key, and then because we can have a few different types of users, we'll have the triggered by type in a string on this column as well. The trigger clip service will also increment the view count for both the clip. This is the parent clip model that was originally uploaded either by the streamer themselves, another streamer, or a user. And then we will also increment the individual streamer clip trigger column as well. The trigger clip service will also send out this clip event to all of the alert consumers. So this will be at the very least the OBS browser source, and it might also be the live control panel as well. So that is when the clip is originally entered into the system. We persist it in the database, we increment the view count, and we send the message real time to the OBS browser and the live control. The reason we're sending it to the OBS browser source is we will have an internal queue that will be kept on this page, very similar to the live control. And the logic for automatically playing the clips I'm planning on having here, so that we don't have to introduce more logic to be sent over WebSockets, we'll be able to keep that functionality isolated, hopefully, to the OBS browser source. For each clip that finishes in the OBS browser source, we'll be able to detect that, and in that event, we'll use the bidirectional communication. This should actually be a double-sided arrow here so that you could see that it can communicate both ways from client to server and vice versa. But when the clip is actually finished playing, we will have the update queue service or whatever that looks like as well. Mark the clip as played, or if it's been paused, it'll update that as well. If it's been played, we're going to remove the last 15th message in the message queue system here, and this will ensure that we're not keeping too many of these. And if we were to do that, the concern there is that we would have the database fill up very quickly because we anticipate this clip triggering sequence and other things like that to happen relatively frequently. So we want to make sure that we're being diligent with the space that's persisting as a result. So this update queue service will handle both updating the clip as being played, deleting the necessary entry in the StreamerKlip queue, and I think this should handle all the functionality. We'll also have the update queue handle broadcasting what is the current time. So the OBS browser source will broadcast that to the update queue. The update queue will broadcast that to live control is what I'm thinking. So in a nutshell, we should have a pretty solid game plan to at least make a first iteration attempt at all of the functionality that we need to encompass here. We'll be referring to this diagram if we need to make any updates. And I like doing this, as you can already tell, because it helps keep all of the functionality in paper and you don't lose track of anything, and being able to visualize it, at least for me, is very helpful. So the first thing that we're doing here is creating a new migration for the StreamerKlip's queue table, and this should all be fairly standard. This mostly mimics what we were going over in the diagram. The one thing that I forgot to include was a status, and this will capture that play, pause, or skipped functionality for us. I did add a StreamerKlip queue, and we're having that belong to the streamer and a StreamerKlip. And I decided to have the streamer ID stored on the StreamerKlip queue object itself because it will save us having to do a joins lookup for each of the streamer IDs. So it felt like a good performance decision to do that. So hopefully it'll pay off for us. And then in Streamer, we have many StreamerKlip queues, and then the clips in queue we will have through it's essentially a has many through table, and we have to specify the source on this. And I haven't tested this to make sure that this works, so we may have to come back and change this, but this is what initially autocomplete and our initial Rails generation came up with. So I had Cursor create our test here, and I just basically explained using speech to text what we're trying to do here with this, and just having it go through and add the validation. So it appears to be okay. I'm going to go through it. All the tests are currently passing, but I just figured I would notate that since I've been using cursor a little bit more for stuff like this, but I might not use it anymore since they're going to start enforcing a more strict limit. So we'll see. But basically what I've been doing is having it model the specs off of other specs that either I've written or that I've already approved from cursor, from us kind of tweaking it. Some of this might be a little bit verbose, but I had it create all of this for us, and it actually added the functionality in all of the StreamerKlip queue stuff here. So we added some validations. We're ensuring that we have a streamer and a StreamerKlip and a position, making sure that the status is going to be one of these here. And then we're doing a validation here where basically if the triggered by and triggered by type is present, we're doing kind of a shorthand operator here. Either they both have to be nil or they both have to be truthy. And if both of those are correct, then it will avoid adding errors to it. Otherwise, it will say where we have one included and not the other. We shouldn't run into a situation where this is going to be the case, but this is why validations exist, to make sure that that stuff can't happen regardless of if you think it can or not. And then for the triggered by type, we have just another custom validation, checking to make sure that that's either a user or a streamer. I just realized we weren't recording when we were going over a lot of the StreamerKlip queue functionality, so I am recording now, and I'll go over what we have so far. We're just setting up validations for some of the columns that we need, making sure that it has one of the expected statuses. And what we've really added is these before validation and before create hooks. We're using these callbacks from active record. So this is what we aim to have handle the set position before we validate, since position is something that's required. We have to hook into it with only on the create and update actions. And then right here, we're just seeing all the entries for the StreamerKlip queue that are currently in for this streamer ID, taking that size, adding a number 1 to it. I just realized that this actually, we only need this to be done on create, because what I just realized was is if we're going to have this called on update, this will change the position size, which is what we want. I have to think about this here. Hang on. Let me think. Let me cook. Okay, so I just got sidetracked there because I think how we were doing this was incorrect. So I made some adjustments. I think it's working now. The specs for this are passing. We'll go over that again. So basically, each entry in the StreamerKlip queue will have a position, and this is how we'll keep track of it on disk. If any of the alert consumers disconnect and need to reconnect, we'll be able to pull this from the database and keep this consistent if that ever happens. This will also take care of the situation where, let's say a clip got triggered, and after the clip got triggered or entered into the queue, the streamer then went to the live control panel to be able to see the queue. In that situation, we would also need to be able to pull from disk. So keeping the position the same here, we're just basically testing to see if we have a created at. If we have a created at, that means that we are updating a entry in the database. If we don't have a created at, that means that we're running on the create before validation hook, and created at hasn't been set yet because that's something that a Rails callback will update for us. So this is a new record if we get to time.current. The reason this is important is we need to find all of the StreamerKlip queues that have been created earlier than the record that we're currently working with, whether it be a new one or an existing one that needs to have its position updated. Another thing that we're adding is the pop last clip. So I mentioned before that we're going to keep only a segment of the StreamerKlip queues in the database so that this doesn't turn into kind of a runaway data situation, right? And there's only needs to be a snapshot of the last 20 or so clip queues in order to get the effect and the reliability of everything that we need, I think. So in the pop last clip, it's a private function, and we are basically checking to see if the streamer's clip queue is at or above the queue size here. And we're just setting this to a constant that we'll be able to adjust if we need to at the top of the file. And so if we have 20 or more of these streamer queues, it will pop the last one, which will just destroy it from the database altogether. Then finally, to make sure that we're broadcasting this message queue to all of our alert consumers, we're using a after commit hook for that as well. We're calling that broadcast. And down here, we're just going to send a payload to our alert consumers, and they'll be able to see that the clip queue got updated, and we're going to pass in the ID of this object as well, and we'll be able to infer whether or not that ID is stored locally in the alert consumer to be displayed, And we'll go over that in just a moment, but that's my thinking there. And I haven't gotten that working yet, but this is the first pass at what I'm thinking to make this work from both a database side and from being able to trigger all of the alert consumers that will need to be able to get this event. So now we're ready to start hooking up the functionality on the controller side of things that will give us the ability to have a request ultimately create a StreamerKlip queue. And as I'm explaining this, I'm realizing that the StreamerKlip queue is maybe not the greatest example because there can be individual records with this, and queue in and of itself seems like it's a group of them. So probably not the best naming convention there. Hopefully it's something that you can still understand, but it will work as we need it to. And if we come up with a different solution in the future, maybe we'll retroactively go back and fix that. But for now, even though it seems like this is a collection of things, they're actually individual models. We have to keep that in mind. So in the create action here, we basically verify that we have a StreamerKlip from the StreamerKlip ID that we'll be getting in from the client. And the reason this is important, as usual, is we need to make sure that it's scoped to the current streamer that's authenticated with the application to make sure that they're not passing in potentially another streamer's clip ID. That would obviously be bad. So we're making sure that it's scoped to this streamer. If for whatever reason it is not a StreamerKlip that we can find, we're going to treat that as malicious and return, preventing a StreamerKlip queue from actually getting created. So we'll just render JSON in an error. We don't need our toast message kind of protocol there because this would be deviating from the order of things, and we don't need to handle that very elegantly. We just need to make sure that it's handled securely. So if we get to this point, we have verified that this StreamerKlip is belonging to the current streamer, and we'll go ahead and create a StreamerKlip queue from our whitelisted params down here. So we'll take in that StreamerKlip ID, the status, triggered by, which will be the ID of whoever actually triggered it, whether it be the streamer or a potential viewer, and then the triggered by type, same thing. It's going to be either viewer or streamer. And then the routes entry is very straightforward. We would just have a trigger clip endpoint that will go to the live controller trigger clip. So in our trigger clip function here, I actually got sidetracked. I didn't realize what this was for, but this is for on the live control in the dashboard for a streamer to be able to trigger their own clips. This is the gateway that we have for this. And right now it's just broadcasting the event to test that that works, and that should be fine. But we need to be able to encapsulate that clip queue create functionality. So we might need to pull that into a concern and make that something that can live in this and be something like include streamer queuable or something like that. Because we're not only triggering clips from this controller here, we'll be able to, again, in the future, offer the ability for someone from the Twitch extension to trigger a clip, and that will require a different controller action with different authentication. So let's pull that logic out instead of having in its own controller, and we'll see if we can make that work with what we already know is working with this server broadcast call. And in going over this, I just realized part of what we wanted to accomplish with this broadcast method is preventing the need to have to do this. So we can actually consolidate this even further by fixing this to include the payload that we already had working for the live functionality. If you're a little confused, it'll come together here in just a moment. We're going to get the existing functionality that we already had of our WebSocket alert consumer being able to display a TikTok on the received when they receive one of these messages. We just need to add that persistence layer with that StreamerKlip queue. So this will all be wired together, and it should look pretty elegant when we're done here. Okay, so what we're thinking here, I'm modifying this as we go. So we were originally just including the video ID and the platform, and that was just for testing purposes. We'll also want the title to display in the queue as well. And we can abstract this by, instead of having a clip triggered, we're going to encapsulate multiple parts of this functionality by just keeping it a little more generic with the clip queue updated. And then we'll be able to derive, based on the local already received messages, whether or not it's a new clip or an existing clip that's changing its status or whatever. Okay, so what I've done here is pull out the functionality from that StreamerKlip queue controller that we were going to use and put it into its own method that essentially does the same thing here. And what this allows us to do is exactly what we talked about before. The controller stays nice and clean. We're including this StreamerKlip queuable concern. And then in the trigger clip, this is the endpoint that will be accessible from the streamer dashboard. We're just calling that method that's accessible in this concern here. And this does all of the same heavy lifting of calling current streamer, making sure that we're getting the scoped streamer clip to it. So I think this will work. And this seems like a much more elegant approach. And when it comes time to be able to trigger clips from the viewer side of things, we should be able to follow a very similar convention with whatever controller that's going to live in, and just enabling that functionality with this here. The only thing that we may have to kind of abstract even further is the current streamer versus current viewer, but we can adjust that and kind of get fancy with that when it comes down to it. Okay, so we just tested the functionality. The idea is we want to trigger a clip, have the clip either start playing if it's the first clip or be put into the queue here, and we have to kind of adapt the functionality on the front end now to send the correct body that they're expecting on the controller, which is this StreamerKlip queue parent object, and we'll go ahead and adjust that now. Okay, in filling this out on the front end here, I'm going over what parameters this controller, specifically this concern, is looking for, and I realized that we need to be able to send in the triggered by and triggered by type. I started to go down the path of making the current streamer ID accessible in this component, but I think having it done on the back end is a little more elegant because we know this is going to be a streamer, and to keep that abstraction of still making this concern work with the ability to have a viewer trigger a clip, I'm thinking we use this kind of pattern here. We're using tap, which just gives us the ability to adjust whatever's going to be returned from this hash here. We'll get a whitelisted variable that we have in the yield here. And what I'm thinking is if we can make a instance variable work that we can set specific to the streamer side of thing on the live controller, if we can make that work, declare that the triggered by is going to be the current streamer, we can follow this convention here and make sure that whether it's current streamer or current user or current viewer, this will be able to work and set up the triggered by and triggered by type automatically without needing to trust any of that information from coming from the client side anyway. So I don't know if this will work, but this is kind of a pattern that I think should work. And if we don't, we will try to figure it out and go from there. Okay, after some back and forth there, we went ahead and made some additional changes to how we're using the parameters. We're not actually using strong parameters right here. We don't need to, because the only thing that we're taking in from the client is the clip ID, and we're going to verify that that's scoped to the current streamer, and the status, which is validated by the active record validations. Everything else we have set up from the server side, and that allows us to create this record safely without using strong params. And then we're just doing some conditional rendering here. If the entry is valid, we'll render JSON, and it'll leverage that flash functionality, and we'll have the ability to get the StreamerKlip queue entry back from this as well. So this will be useful for adding to the existing queue on the front end for the streamer dashboard. So now that that's working from a streamer dashboard perspective, we have to make sure that on refresh and all that kind of stuff, it is working. So as we can see in the Docker logs here, we are seeing that the ActionCable request is getting set up. So this appears to be working correctly. We just need to modify the alert consumers to digest this. So this will be the OBS source and the streamer dashboard for the live control to be able to actually input that message queue entry into the dashboard there. But from a theoretical standpoint, at least, this appears to be working from what we're seeing in the logs, and we are getting a 200 now when we press trigger clip. So that gives me hope that the only reason that we're not seeing this here is because we haven't built it out yet. So that's what we'll do next. While I'm in the middle of this here, we ran into an issue with our as.json method here. So we're trying to get the StreamerKlip queue. And if you hate that model name, I'm right there in the same boat with you. It's probably a bad decision. We probably should set this up to be something more like StreamerKlip queue entry. Something like that would make more sense. But for now, this is just the decision we made, and it presents a good opportunity on how we can kind of strategize refactoring this in the future, and also touches on, like, is this important enough to figure out the namespacing, the directory structure? Because I don't know that off the top of my head. That's a common thing that I would have to kind of like experiment with in order to get going. This is working. It may not be the best, most explicit name of the model. We're aware of that, but we're going to continue. Anyway, the as.json method we're overriding here. This is a method that gets set up from active record, and this is how Rails is able to serialize the columns in the database into what you'd expect in a JSON format. So we're able to call the super method on it, which it calls in Ruby the hierarchy. You're able to monkey patch or override a class method like this, and you can call the parent definition of super, or of the method that you're defining. So super is actually calling the parent method on this class here, and we're able to leverage both. It's kind of a meta programming thing with Ruby. So we're leveraging that here to include the records that we need. So on this StreamerKlip queue, we're including the StreamerKlip so we can get the title for it. We're including the clip itself so that we can get the actual platform ID and the platform. These are columns necessary for us to actually render the TikTok clip, right? And this is the same thing that we'll use for other platforms when we start to support them as well. And then we have this triggered by, and we went over this a little bit before. Triggered by is going to be either a streamer or a viewer. And so since it can use multiple, it could be one model or another, we're going to create an association that can support that. And in order to do that, we're going to leverage the polymorphic association that Rails allows us to do. And so if we're leveraging this on the triggered by, that's kind of the declarative name that we're starting this with. From that, Rails will derive two different columns that it's expecting now on the StreamerKlip queue table. Triggered by _ID and triggered by _type. And this is how we're able to use both a streamer type and a viewer type to have an association to this model here. And we're able to do that without having to explicitly check the class names and do all of that. It's just following the Rails convention. And so we're able to get this going. It can be a little tricky sometimes, but now what we've just got going is we're getting the payload that we would expect here, right? Or the JSON that we're expecting here. We're getting all of the clip information, and we're not having to go out and fetch that. Rails is doing that under the hood for us, and this does leave us vulnerable to N+1 queries. I think we went over that as well, and we'll keep that in mind, but we're in the stage of just getting the functionality going, and getting the functionality going in a way that isn't just hodgepodged into the application. There's true intent here. We're being diligent with every step of the way. And when we're able to abstract certain things like this, it allows for us to improve upon it in the future a lot easier. So with this polymorphic association, we're now able to associate a StreamerKlip queue to being triggered by either a viewer or a streamer. And this is a really great call out to why Rails is amazing. The convention that you follow is almost something that you can understand as a layman in clear terms. If you were to draw this out in a diagram, it would make sense that we're able to have this association, and the fact that it just works like this is amazing. So we're able to have that triggered by functionality work here, and then couple it with the other associations. And what we're proving the concept of right now is we just created a StreamerKlip queue entry in our database, and when we call as JSON on that now, we're getting exactly what we expected back here. Now, initially, we were getting user here, and the reason for that is we are using user as the model that's in the database, but we're able to abstract that using single table inheritance, meaning both a streamer and a viewer can have, if you look at it as a pyramid, both of them are a user, right? So that's what single table inheritance is. In this context here, it added a little bit of complexity because the normal convention for Rails will show user here. User is not very helpful for us because the reason we have these two different models is because they're treated differently in different parts of our application. We need to know that. We need to know that here as well. So now we're able to, we just used AI here, cursor, to ask, how do we override that? We're using polymorphic associations. We're trying to get this triggered by to leverage that. And we also have single table inheritance that we need to account for. And a great testament. This is something 5 years ago or even 2 years ago I would have probably looked on Stack Overflow for, because I just don't remember this kind of stuff. So on the different models, you can declare what you want to be returned. This is the method on the class that Rails is going to call in order to get the value. By default, it will trickle up to that user table. We can override that. If we go to the streamer model here, we have a class method indicated by the self dot here, if we didn't have that self dot, it would be an instance method, and that's not what Rails is using. It's using the class method for these objects that it's working with. So we just have simply streamer is what we want here. We could have put the class name here, but just having it in plain text, I think that you can see makes it more readable. So we don't need to get fancy with this. And so this is where Rails got that name to populate this when we created the StreamerKlip queue record. And now if we had a viewer model set up, we would be able to do the same thing. So that'll serve us in the future, being able to differentiate the two. And now we can easily see that this payload will get delivered via our alert consumers and will have the display name, which is what we were ultimately after, being able to see this clip was enqueued by this user. And we need to see that for if it's the streamer themselves or the viewers. This is what we'll have to build in the functionality on the front end. But now we have the ability to display their name and the type that they were, even if it's just for the purpose of the streamer dashboard. We're making some progress with the proof of concept here, and I'm just playing around with this in development. So far, what we have working is the queue React component here is set up to listen to the stream alerts channel so that it can consume the payload, which is the actual StreamerKlip queue object. And it adds the queue element once it receives that message that comes through. And then we also are able to skip that item, which ultimately destroys the StreamerKlip queue entry in the database. And we're relying on that WebSocket connection payload to deliver the event that happens, so that we are actually updating the queue here if it's made its way all the way through the entire pipeline and the entire process. So we're still using the default Rails as JSON include stuff, and we're sprucing it up by including the StreamerKlip for the title and the clip itself with the platform ID and platform. So in the actual model itself, we're using 3 different after commit hooks two after commit hooks, 1 before commit hook, and we're basically communicating the database update, destroy, or create from the model itself to ActionCable and all of our alert consumers. So we have 3 different callbacks here so that we can call the corresponding type in the payload that will get sent, and we consume that in our React component and update the UI accordingly, whether we're updating the state of a component or we are destroying a component or adding a component. So we're hooking into the active record callbacks there using the after and before commits, and that introduced a issue with our StreamerKlip queue spec, the model spec itself. Since by default we're using transactions in all of our tests, we had to declare specifically for this test to use database cleaner and the truncation strategy. And what this will allow is for these after and before commit hooks to actually fire, because in a transaction the database commit never occurs. So it's something to keep in mind if you're going to use these callbacks here. In order to be able to test that and have it run in the test environment, you'll have to find another strategy for that. Inside of our React component here, this is what's actually showing in the queue in the top right hand corner, and we are basically on the component mount using the create consumer method from the Rails ActionCable npm module. And this is where we're going through each case for the different types that we can have here. So we need to account for updated, destroyed, and create, and we'll update that accordingly here. So either adding it to the collection and state, or updating the existing record and state if the status of it changed, or removing it altogether. So when we actually press the skip button, this function gets called. That sends the request to remove the StreamerKlip queue in the database. And then eventually, after we get to this point, right before the destroy is being committed to the database, we want to call this out through ActionCable to make sure that that's getting updated only in that case there. In situations where you assume that the request is going to succeed, in the event that it doesn't, and you've already updated your UI, in the case of this kind of queuing system here, it provides a bad experience. There's any number of things that can cause that to go wrong. And so accounting for multiple states being updated at the same time through this kind of server-side way of communicating that, I think, is the way to go. So we have the ability to queue up items here. By default, we have the currently playing B being the #1 position in queue, and we're just going to have that here to show and illustrate that it's currently playing. We're going to add a pause and skip button here. But we need to wire the rest of that functionality together where the queue is actually being managed, and after the clip is done playing, we need the browser source alert consumer to handle queuing up the next message and updating that in the database so that it can be updated here and anywhere else that they may be using this interface. So we'll start to work on that next. We also modified our StreamerKlip queuable concern to encapsulate the functionality that we'll need for all of this operations, the create, read, and update, destroy, on our StreamerKlip queues. And we'll need that in the streamer dashboard and in that alerts view that will be another alert consumer, as we'll refer to it as. And the reason that this will be separated in logic mainly is because of how the requests for the two different controllers will come into Klipshow. So for the alert side on the OBS browser source, that clip is again authenticated with that token in the URL versus the cookies that we're setting in the headers for each request for all the requests that are made in the streamer dashboard. So to be able to not have to write functionality twice, we were able to abstract that functionality into this concern here and use them in both controllers. So the underlying code that actually takes care of creating a StreamerKlip queue that's scoped to the correct current streamer all happens within here. All those index and all those actions happen, and then we declare them and invoke them in their corresponding controllers. So in the StreamerKlip queues controller here, we're including two of our concerns. We're including dashboardable, which is how we get that cookies authentication for the current streamer setup, and we're including the StreamerKlip queuable in order to encapsulate all of the functionality needed for this. Now, since we're including the dashboardable concern, we are having a before action hooked into that authenticates the streamer. The authenticate streamer eventually sets that at current streamer instance variable. In our base authenticatable concern that this is in here, this is what ultimately gets set. If you'll remember in, I believe it's episode 1, where we went over the setup for how this will work, the reason that we're using this pattern is so that we can make sure that we have an instance variable set and cached for the duration of the request. So the way that we're able to follow this convention here allows us to take advantage of not having to declare that we need to scope the current streamer to the user that's signed in. That can be taken care of for us. And what we're left with is a very clean, very tidy, very self-explanatory controller that is not bloated, and we're able to accomplish keeping things dry, or don't repeat yourself, and keeping the code very readable. And we're doing that because these Rails conventions that have been set forth for us have proven to scale well and create very nice to work with code. And so the more that we lean into that, the more we're able to take advantage of not having to reinvent the wheel and making sure that we still have all of the great foundation that we need to continue to build everything that will make Klipshow ultimately work. Okay, so I just got done on a heads down situation here trying to get the StreamerKlip queues renamed, and we're going to treat them as if the resource name is a queue, like a card queue, and I think that'll work. And so we're going to go over the different namespacing that we had to do to accomplish that, and kind of the inspiration for why we did it. So in models here, we added a StreamerKlip folder, and in that folder we added the queue.rb. And instead of StreamerKlip queue as one word, we're going to keep it namespace to the StreamerKlip, gives it this kind of nesting capability here, and I think that helps illustrate what it should be looked at as. Instead of a queue as in a group of things, you need to start with the individual item, and the individual item will be like a queue, like a card queue. And so this, I think, illustrates that a little bit better. So we just had to update the structure for things, and we did some changes in the routes file. Before we were using this live control kind of namespace, and I went ahead and got rid of that. And we're going back to kind of a more Rails traditional way of doing it with these resources. And so we're declaring the clip's path. I remember mentioning that earlier in the video, that the initial turnoff for wanting to do this was I wasn't sure how we would be able to specify, I don't want streamer_clip_queues in the URL. Clip/queue follows a better scheme for that, I think. So just changing path to Clip's queue seemed to accomplish what we needed to there. If we run our Rails routes helper there, we'll get a generated list of all of our routes, and we can see how this is being coordinated. And this is really where this utility comes in handy. So we have a index action, create, update, and destroy. And there's 2 for update because they have 1 for patch and put. But other than that, we're just doing the index, create, and destroy, update actions. So this allows us to have all of our URLs follow this scheme here, and then we're still taking advantage of kind of that RESTful approach with keeping the ID in the URL itself instead of using query parameters, which is what we just were doing in the original proof of concept here. So in the application, I changed live control to just queue. I think this makes sense a little bit more. And then the Klip queue, it's all the same experience, but now we have a namespaced environment for this particular resource, and I think that helps illustrate what we're trying to do a little bit more. And what was the inspiration behind this was, if we're having a hard time grasping what a model is representing, it should be a kind of gut reaction for a developer to stop and say, am I doing this not the way that follows the convention of the framework that I'm using? Particularly Rails. We have a lot of documentation on Rails and different examples of Rails applications that have scaled that we can look at and take those patterns that have proven to work over the course of scaling from just a single developer to 100 developers. And what I found myself realizing was it didn't make sense, and I commented on it earlier, and that's why we ended up making the change. So I think it's an important call out to try to keep things consistent while having that balance again of trying to get a proof of concept working, right? I didn't let the initial hesitation in our naming convention prevent us from building out the core functionality of the proof of concept here. So now that the proof of concept is working, we're able to implement an improvement based on the functionality that we've already gotten working. So wanted to give that a call out here, and I think that it's an overall great win for the structure of our models and controllers and naming overall. But naming in general, it can be very difficult, particularly when the action or functionality that it encapsulates isn't easily describable in a traditional object, because we're working in an object-oriented programming language. So we have to keep that in mind as well. But overall, again, I think this is a win, so we will trek on. So just like how we're able to include these actions that correspond to where the routes file is directing each request, we're able to say index goes to the index StreamerKlip queues method, and that StreamerKlip queues method ultimately comes from this concern. We're able to do the same thing with that separate alerts controller that we can make sure we're handling that authentication with separately, because it's different than the cookies-based authentication here. So in this controller, this is what the browser source will be able to access, because it has that token to use in each request that we can use to verify each request coming from that browser source is something that we can trust. The reason for that is we are going to have the OBS browser source React component be in charge of actually driving the Klip queue. So when a clip is done playing, we'll be able to hook into the iframe event that TikTok sends for that, and we'll be able to have that React component make a request to the controller to manage the StreamerKlip queue entry in the database. And since we're managing all of the broadcasting over WebSockets through the active record callbacks, we'll be able to very intuitively have our interfaces designed around the database state as it changes. So if a clip updates from queued to played, we'll be able to account for that and have the TikTok preview automatically start playing when that clip status changes. And if we skip a clip, it will update that as well. So we'll have a total management system for these StreamerKlip queues, and we're not really having to do much coordination because it's all based around these active record callbacks and this other functionality that we're able to replicate in 2 different authenticated spaces. So we're really leveraging how Rails sets this up for us, and this is really a great testament to why Rails has served me over my career and why I've never needed to abandon it. This type of layout and framework would have taken probably weeks to set up properly in order to have it accomplish everything that we need, and we have all of this and more already at our fingertips. As you can tell, I'm very excited about it, because I mean, this is just, when it comes together, it's a very fulfilling thing. You kind of, it feels right, the puzzle pieces kind of fit together better, and you're not having to brute force these kinds of things together. So hopefully that's what we'll end up with here. But I am going to go heads down for the next little bit of functionality, building out that specific kind of player functionality based on when the TikTok video is playing in the browser source, and then making sure that the request gets to this controller, subsequently, whether there is a subscriber in the streamer dashboard side of things or just the OBS source. Regardless, all states and all UIs will be able to account for the different state changes in these queuable kind of models in the database. In order to debug why we're not able to have the same functionality in our OBS source as we are in the browser source, we need to figure out how to get OBS debugging working so that we can see the browser source in the remote Chrome DevTools environment, which is the same thing we were trying to get for our own integration test working. This should work, however, because the OBS Chromium broadcast source is going to be on the same network adapter as the rest of our machine, since we're not having to go through a network interface like Docker's virtual network adapter that we have to kind of network address translate through, and that's what we ran into before with not being able to do that. So I did some research, and in order to enable remote debugging for all of your OBS browser sources, you need to launch OBS with a particular flag, 2 different flags actually. And this would be similar to how we launch programs from the command line. And when you click on an icon, essentially that's all what's happening is there's a command that's being run where the actual file is installed or where the actual program is installed, and then runs the executable. And the executable a lot of the times can accept these parameters. So it's not super intuitive, but this is how this is able to work. It's the same protocol and the same flags that we were playing with before, minus that remote debugging address flag being on there. We were able to set that to 0.0.0.0 before to bind to all network adapters, and that was that security flag that I think Chrome has done away with. Chromium itself might not have it, but anyway, in order to get that working, we had to add the remote debugging address, or excuse me, the remote debugging port. We're setting that to 9222. And then we also had to set remote allow origins localhost 9222. So this should now allow us to go to that address, localhost 922, and get the Chrome debugger tools working. And I have OBS running right now. It's actually the software I'm using to record this video. So OBS is running. It's accepting web requests on this port, and we should be able to debug our remote OBS source for the alerts here to get some more information. If we go to localhost 9222, we will see that all of these are the different browser sources that we have access to, and the one that we need is called Klipshow Streamer Alerts. So if we go there, we'll see a black screen, and we'll be able to look at the actual source code of what OBS is rendering. So this is hugely helpful to try to debug this. Now, I've actually already figured out what the problem was. It was a very strange and obscure issue. We were in our React component here, we were using the same controller endpoint as the streamer is going to use in the streamer dashboard. And the reason that doesn't work is because, again, they're treated differently with their authentication. One is being authenticated with a token, one is being authenticated with a signed cookie. So I had the wrong URL in here, and I wasn't able to see that because when we ran this in our browser, the browser from localhost 3000 has the cookies set in order to authenticate with that method, which is why it was working in our Firefox, or what we can see the actual source code for before having to enable debugging for OBS. And so I just wanted to illustrate how I came to that conclusion. The OBS debugging was still crucial because I was getting a 404 error when those fetch requests were made. And what was happening was the pre-flight request, which happens in a AJAX or CORS-based system, was redirecting the user to the dashboard because we were inadvertently trying to authenticate them using that cookie approach. And in this context, that doesn't work. So we added a few routes here in order to make that happen. We're doing the show action to actually render what the component shows up in, and then we're using this here to update and destroy the different StreamerKlip queues that the browser source needs to control. So we're able to follow the RESTful pattern here. We're using token in the params, and then ID of the actual resource in this case is going to be that StreamerKlip queue, and then all of these are being routed to the alerts controller. If we open up the alerts controller here, we can see that we clean this up a little bit. We don't need all of the methods that we had before. We just need show for the actual rendering of the component, update to have the status updated from queued to played or from played to paused, and then destroy for when a clip queue has been played all the way through. So we don't have as many actions as we need on the streamer side of things, on the dashboard side of things, but we're still able to use that concern, the StreamerKlip queuable concern, to take advantage of that. And the biggest difference between the two controllers is this before action here. We're setting the current streamer to an instance variable, something that's handled for us in the authenticatable concern that we use for being able to set the streamer's instance variable and all that kind of stuff based on that signed cookie, and then decoding it, making sure that the ID from the OAuth token and all that kind of stuff is taken care of. Since we don't have that here, we need to use that same pattern of setting current streamer to an instance variable so that all of the methods in our concern can properly scope all the StreamerKlip queues and all that kind of thing. So we have to set this a little differently because we're finding the streamer based on the token that's being sent in. So this is why we have to separate the controllers to keep the business logic separate enough to be able to clearly illustrate that this is being treated differently from a authentication standpoint. But essentially it does the same thing, just in a different way. So I have Klipshow loaded in our OBS here, and if I trigger a clip, we'll see on the actual OBS here that it's playing, and so we don't see it here on Klipshow. It's not, you know, you can see the cursor disappear because the TikTok is above there. So we don't have the ability to skip yet, and that's going to be the next thing that we need to do. But after this clip here ends, it's only 30 seconds, so I'll just talk through it. After the clip ends, it should update here in our streamer dashboard that there isn't a clip currently playing, and then it should also hide the TikTok player in the OBS browser source there, which we can see that it just did. So after the video ended, it updated our currently playing to not show that that's going on, and then there's nothing in the queue, so that needs to stay empty as well. And what happened behind the scenes was in the streamer alerts component here, we are on that callback that we added for that TikTok preview. When the video is ended, we're having it go to this handle video ended callback function, and all that's doing is deleting the StreamerKlip queue from the streamer's from the database. And since we have our active record callbacks hooked into when one of those resources gets updated, created, or destroyed, it sends out a broadcast over WebSockets to the consumer for OBS and to the browser or to the streamer dashboard as well. So we're able to keep the entire queue synchronized over WebSockets, and that how it's working is we're using kind of a semaphore pattern where we can queue up items, and what will happen given our callbacks and the alert consumer here that drives this actual functionality, when we are done playing a video, it will get deleted, and then the next clip will play if there is one in queue. And so that's following kind of that semaphore pattern of the queue is dependent on the previous clip running and executing its callback function to queue up the next one, and so on and so forth until there's no more clips left in the queue. Another thing that's worth mentioning is the custom hook that we're creating in React to handle the concurrent connection to the StreamerKlip queue broadcast channels, and being able to make sure that the data collection locally stays in sync when these messages are received. So we're able to reuse this by creating a custom React hook, and this is one of the great patterns that React offers. So instead of having to use this in two different components and have to copy the code and use two set state and all that kind of thing, we can abstract that into its own hook that uses under the hood the use state to keep the StreamerKlip queues stored locally. And then we are able to use another nice function here, use memo, which is a memoization function, indicating that every time the component renders, we don't need to change the order of our or adjust our collection for the StreamerKlip queues. We only need to do that when these change, and we're also able to hook into that and sort it based on position, so that no matter what order we get the events in, we're going to make sure that the positions stay the same. And the position is dictated based on the created at timestamp, and that will change based on what order it is in queue and that kind of thing. So this is what it looks like, and we're putting that in the shared hooks use StreamerKlip queues file, and then where it's actually being used is in the streamer alerts here. So this is what we just went over that actually handles playing the next clip and all that kind of thing. So instead of having to call set state for our StreamerKlip queues here, we're just going to import StreamerKlip queues, passing it in the URL that it needs to connect to initialize the WebSocket connection and be able to have those events sent into it. and then we're sending it the initial value that we would like that underlying use state to set the initial StreamerKlip queues to. And this will be on initial page load, whether it be on the alert side of the OBS browser source view or in the streamer dashboard. The initial load will load this from our props here, and we'll pass it into that collection. So we're able to use it here in the streamer alerts show component, and then in the StreamerKlip queues component that we're using on the streamer dashboard, we're doing the exact same thing. We're passing it in from the props, that StreamerKlip queues, ultimately being rendered from the show.html page for the alerts page, and then for its corresponding view here for queues. So we're able to pass that in from the Rails side of things, and it's another nice side of having this kind of hybrid approach. We're able to pass these props in without having to worry about server-side rendering or anything like that. So just wanted to go over that custom hook functionality. This takes care of subscribing to the events, updating the queues, and making sure that they're synchronized. And I just realized we have a duplicate here. I don't think we need this, so I'll go ahead and remove that. But this is where it originally started. I created it in this and then abstracted it into its own hook because I know we would be using it in multiple places. So adding on to the functionality here, we can see when we add a clip to queue, and we just changed the verbiage here, we can see the currently playing clip, and it's playing in OBS right now. Added the ability to pause, so we can press pause, and then we have a state management here that changes this button to play if we've pressed pause to put it into a played state. And then we also have the ability to skip, which will just delete the clip altogether. And that is pretty much the MVP built out. We'll have some additional steps here. We'll need to make this a scrollable list, and we need to change our validations a little bit. Currently, we have our logic set up to automatically remove the next clip in line if it's above that max number that we have in the StreamerKlip queue model. And I'm going to change that to only allow whatever that max queue is in there. So we're not going to lose those clip queues as they come in. And the reason for that is the decision is a little different than what we initially anticipated we would use that for. So we have to do that. And aside from that, we might add a purge button here. So if we have an entire clip queue like built up, we can go ahead and purge it if that's an option as well. And we'll need to handle that in a little bit special way, because right now when an individual clip gets skipped, the after destroy callback is what gets called and updates for that individual clip being destroyed on the front end. Since we're doing this in a batch process, we're going to do this a little differently to where we don't have 20 different requests coming through to delete those individual StreamerKlip queues. So we have to keep that in mind, that every time we send a WebSocket message, that does translate to an HTTP request that the Rails server has to process. So although the Rails server isn't holding on to that concurrent connection and tying up the thread indefinitely, we are still processing those requests that get sent over AnyCable via HTTP on Rails. So we have to be mindful of that. And then this isn't a situation where we can just have a special command for deleting all of the clip queues, and that will be easily digestible by our 2alert consumers here. Okay, so we've worked out some additional logic around the clip queuing system here. And I will go ahead and disable the Klipshow browser source in OBS so it doesn't display while we're doing this, because it's not relevant to what I'm trying to demonstrate. So we'll put a few of these messages in the queue, and we can see that we don't have the play button right here. And the reason for that is our logic in the UI looks at this current StreamerKlip queue, and if it has a status of play, it will show the button. If not, it will only show the skip. And that is intentional because we're actually not playing it, so you can't pause it and you can't play it because the status of this is still queued. And so that really plays nicely into how this entire message queuing system works and how we're able to leverage React to make our custom hook that we can use for the StreamerKlip queues. And that's reusable for both places where it's being used. And each time that one of our clip gets rendered in a different state, React will pick those changes up and eventually disable or change the context here or the content here, as well as in the OBS source. So we added a clear queue function here, and we also added in parentheses the number that is in the queue. And we also added a maximum height on this component here so that after the maximum amount that it can be displayed, given the TikTok preview here, it'll scroll. So we have that. And then we've added a two-step process here for clearing the queue. You have to confirm, you can cancel. And then if we confirm, we're not having to do anything extra on the back end here to make sure that the UI gets into the state that we need. We added this clear queue method here. And what this does is make a delete request to a new endpoint that we added. We added that with this collection notation here using the resources method. And we're basically able to follow this RESTful syntax here and add our own endpoint to have this custom action clear here. And as I mentioned before, we didn't want to set individual requests to delete them. That wouldn't make sense. That would be that would be unnecessary. And we don't want to have the callback functions from Active Record trigger on this, because that would trigger, again, HTTP requests eventually, even though it's done through WebSockets on our Rails server, and that wouldn't make sense either. So in this case here, we're doing all of this in one request, one round trip. We're doing a delete method here. The delete method, it comes from the StreamerKlip queuable concern. And as you can see, instead of having it in the callback, we're just broadcasting this event, this custom Klip queues cleared event, right in our controller. And that allows us to skip those callbacks altogether, because destroy all on this collection here does not call all of the callbacks. It's kind of a feature of Rails. If you do destroy all, the callbacks will get skipped for what will trigger, in our case, the ActionCable broadcasts that otherwise would get run. So this is following a very great pattern, I think, and when we change this stuff, we're not having to account for additional functionality to change the UI state. I know I've said that multiple times, but it's just so important that that's what we're able to take advantage of here. And we're able to not even have to do a page reload. And I know some of you may be thinking, oh, you could use turbo streams for a lot of this functionality. And I'm sure that there could be a solution around that. The reason I didn't go that approach was because I wanted to have this kind of dynamic functionality in the frame itself that we would need some JavaScript for, right? So since we're already able to do that with React, and we can use a lot of the nice React patterns, like making your own custom hook, it just seemed to make sense to go this approach for me. So underlying technology is still pretty much the same. We're using ActionCable with AnyCable and the HTTP RPC stuff. All of that is going to be the same. We're just having a lot more control over it with this React portion by having the ability to change the UI so easily for both the preview and for what actually shows up in OBS. While writing some of the system tests that we'll need for the functionality that we just got working, specifically around the ActionCable WebSocket stuff, we ran into a few issues with the testing environment and making sure that AnyCable is set up correctly and we're able to hook into the event when a subscription is actually made on the front end, so that we can actually trigger our WebSocket message, which will change the UI and what our test ultimately is around. First thing here that we'll cover is I added another instance here for AnyCable, and this will be dedicated to the test environment. So the reason for this is the environment variables that are set up for the AnyCable image normally point to our web hostname here. And since we're testing this in the test environment and having our own test server, we need to be able to isolate that. So we added another AnyCable instance here specifically for testing, and we changed up the port numbers here slightly from 8080 to 8081 so that we would know the difference there whenever we see that. And then we're able to set the AnyCable RPC host now to our test host, which is where the test web server is going to be running. So within the context of our tests, we'll be able to use this isolated AnyCable instance to make sure that it's not going to conflict with the web server and unsupported functionality and that kind of stuff. We also had to introduce a little bit more logic in our ActionCable URL, and the ActionCable URL is what gets sent into, in this case, the alerts React component that is what shows up in OBS. So by default, this was working in development because we only had port 8080 that we were getting to AnyCable on. Now that we have a different host, potentially with the new isolated AnyCable instance, we had to account for that. And so we're just doing that with an environment variable. And then in the test service here in Docker, we're just setting those environment variables so that we can have the AnyCable test be the host that we're having the front end connect to and ultimately get wired into the isolated instance for the test purpose. Another incident that I ran into was needing to make sure that in our test, we were able to make sure the front end is connected to the Streamer Alerts channel before we send the broadcast message and then make our assertion that that TikTok preview is there. In our show spec here, I verified that that was the issue by putting a sleep, which is just a Ruby command for having the program pause for how many ever seconds that you declare. And when I would do that, it would connect and our test would pass. So what I came up with was having our React component, specifically that custom hook that we use for subscribing to the Streamer Alerts channel, and making sure that the collection is synchronized with the StreamerKlip queues in the database. We modified that to use a callback when the subscribed method is returned on the ActionCable NPM module kind of method. And what that does is it sets something in our DOM that we can look at, and we can have Capybara wait for that element with this selector here to show up, indicating that at this point, the client is connected and ready to receive messages from ActionCable. So this was the final piece of the puzzle here, hopefully, to make sure that we have a solid framework for being able to, as close to production is going to be, testing the AnyCable interface and the dependencies that are required for that, and then also making sure that we have a reliable way to write tests for it, and that we won't have false positives or false negatives based on these types of race conditions that can happen. You have to think that in this environment, we have to make sure that the test is actually in the scenario that we need it in order to adequately test. So the reason that this was so crucial was we would have this broadcast before the alert page was subscribed to the events that were coming through on the channel. So this was ultimately failing because it never received it because of that kind of order of operations. So very important to do that there. And then how this actually works is in our shared hook here. When we set up our consumer on the alert channel, there's a callback method that the ActionCable package is giving us here called connected. And then we're just using this in the form of a callback here. So when we instantiate the user strip use StreamerKlip queues, we're passing it in a callback function here. And then how that's used in the streamer alerts here is when we call use StreamerKlip queues, we're passing in this set subscribed here, which is just the standard React hook for managing that state. And then we have a wrapper for our TikTok preview. And this is where we're getting that data AnyCable subscribed. This will only show as true on this element once all of that kind of takes place. It seems to be working, and it was worth giving a call out there to all the stuff that we had to do. We also had to set the the server for Capybara to a different port. You have to remember that we're running this in Docker, so the web instance would be running, and I found that out accidentally by looking at the Docker logs. Our requests from our system tests were showing up in the web logs, and that's not what we want. We want that all isolated in the test environment. And so to do that, we had to make sure that we're specifying a different port for that to run on, and then for the server host to be accessible between the Docker services, we had to bind that to 0.0.0.0. This remote debugging, I gave it another shot to try to get that working. Got it kind of working locally, but so far it's still just having it run locally in the Docker service there. So now we will be able to write the rest of our tests specifically around the queues portion of the streamer dashboard, and we'll follow the same pattern here unless we run into another issue. We're going to go ahead and wrap it up now because this is already a very dense technical episode. At this point, we should have a good grasp on the pattern that we're following for getting this StreamerKlip queue system to work using a Semaphore pattern, which is a great CS fundamental for all of us to brush up on. I'm really glad we were able to get that polymorphic association sorted out so that we can make sure that when we are viewing those types of models, we have a good grasp and understanding on what Rails can do for us in that way. And we're starting to get to the point in the project where refactoring is something that is going to occupy more space in our mind because we have more moving parts, more code, and we need to make sure that this is going to scale for the long haul. What I'm most excited about in this episode that we were able to accomplish was the robust and very intuitive queuing system that uses React on the front end and all of our ActionCable, AnyCable setup in the back end. The reason this is such a great accomplishment, in my opinion, is whenever you have this type of situation where in real-time events there are multiple consumers of those events, it can be inherently tricky to get those to synchronize and to work the way that you expect it to. So far, we've seemed to have proven that it is working the way we want it to, and until we find an issue with that, we'll go ahead and battle test this until MVP is completed and beyond. As a reminder, we do stream every single day on twitch.tv/oddjob, where we do a little bit of gaming, but mostly coding, and we're all very excited about the progress that we make live on Klipshow, and we'll be sure to carry that into other projects and other code-related stuff. So be sure to follow right now so that the next time we go live, you'll be there and won't miss any of it. Thanks so much for sticking with me on this complex episode. The foundation we built today is something that will serve us for the rest of this project, and I'm so excited to get some functionality working in the sense of getting this hosted to production, getting our continuous integration pipeline set up, and ultimately getting to that viewer extension, which is where Klipshow might actually start to become a business by giving the opportunity for people to spend real money to trigger these clips for streamers. Episode 6 is already underway, so I will see you there.